in my YouTube video channel of Engineering Graphics and Design subject. Myself Aarti Patel from LJ Institute of Engineering and Technology. In this session, we are going to start the new chapter which is Isometric Projection and View. So first, let us understand what is Isometric Projection and View. Isometric projection is a type of axonometric projection. Axonometric projection is a type of orthographic projection in which rays of sides are parallel to each other and perpendicular to plane of projection. The details classification of projection we have already studied in Projection of Point and Line chapter. There are three types of axonometric projection which are isometric projection, diametric projection and trimetric projection. In isometric projection, you can see here equal angle of three faces which are alpha is equal to beta is equal to gamma is equal to 120 degree. So in isometric projection, three faces are equally inclined with each other and inclination is 120 degree. In diametric projection, you can see here equal angle of two faces. Here alpha is equal to beta. In trimetric projection, you can see here different angle of three faces. So alpha is not equal to beta is not equal to gamma. The purpose of isometric drawing is to understand overall shape, size and appearance of an object prior to its production. Isometric means same, similar or equal. So, in isometric projection, three lines of length, width and height are meeting at a point and making 120 degree angles with each other is called isometric axis like three coordinate axis x, y and z. Here you can see x, y and z axes are equally inclined with each other and the inclination angle is 120 degree. If length is taken on x-axis, then take width on z-axis. If width is taken on x-axis, then take length on z-axis. Now height always fix on y-axis. Now next let us understand how to complete isometric box according to length, width and height. First draw horizontal reference. From horizontal reference, draw 30 degree angle line which is indicate x-axis. Here length is taken on x-axis. Next draw z-axis. Angle from horizontal reference is 30 degree and take width on z-axis. Next draw vertical y-axis and take height on y-axis. Here you can see the angle between two axes is 120 degree. Next complete isometric box. From end point of this height line, draw parallel to x-axis or length line. Next draw parallel to y-axis or height line. Next from this point draw parallel to z-axis or parallel to width line. From this point draw parallel to y-axis or parallel to height line. From this point, draw parallel to x-axis or length line and from this point, draw parallel to z-axis or width line and complete isometric box. Now, the angle from horizontal reference is 30 degree. Now, isometric projection and view or drawing is a reverse process of orthographic projection. In orthographic projection, as a question, 3D object is given, and according to 3D object, we need to draw its 2D projection or views. Now, in isometric projection and view or drawing, here as a question, 2D projection or views are given, and according to 2D views, we need to draw 3D object. Next, let us understand what is the difference between isometric projection and view or drawing. Isometric view or drawing, it means drawn by using true scale or true dimension. Isometric projection means drawn by using isometric scale, or it's called reduced scale or reduced dimension. Next, let us understand how to find reduced dimensions in isometric projection. Here you can see isometric box for length, width and height is given. Here length is taken on x-axis, width is taken on z-axis and height always fixed on y-axis. The angle between two axes is 120 degree. The angle of these two face or this two line from horizontal reference is 30 degree. Now in isometric box, the shape of this face looks like a rhombus, but actually it looks like a square. First, take top face of this isometric box. Mark here corner points as A, B, C, D. Next, connect AC and BD diagonal, which is intersect at one point. So mark here O point. Now this AB line indicate here isometric size, and the angle of this isometric size line from horizontal reference or this AC diagonal is 30 degree. Now actually this face shape looks like a square, and the angle of square side from horizontal reference or horizontal diagonal is 45 degree. So from A point, draw 45 degree angle line, and this line indicate true size. Next, extend this OB vertical line up to this true size line and mark here B1 point. Next, take triangle OAB and find out cos 30. Now cos 30 for triangle OAB is equal to nearest side upon hypotenuse side. Nearest side is OA and hypotenuse side is AB. So cos 30 is equal to OA divided by AB, and the value of cos 30 is equal to root 3 by 2. So AB isometric size is equal to OA into 2 divided by root 3. This is equation number 1. Next, take triangle OAB1 and find out cos 45. Now cos 45 is equal to nearest side divided by hypotenuse side. Here nearest side is OA and hypotenuse side is AB1. And the value of cos 45 is equal to 1 upon root 2. So AB1 true size is equal to OA into root 2. This is equation number 2. Next, take ratio of equation number 1 and equation number 2. So AB isometric size divided by AB1 true size is equal to OA into 2 divided by root 3 into OA into root 2. Here OA cancel. 2 is root 2 into root 2. So root 2 cancel. So final value is root 2 divided by root 3 is equal to 0.816. So isometric size is equal to 0.816 into true size. So, isometric size is reduced by 0.816. Here, this is indicate isometric scale or reduced scale. Next, let us solve example of isometric scale or reduced scale. Example 1. Draw an isometric scale of 100 mm length and show 55 mm length on the scale. First, draw horizontal reference line AO. From A point, draw 45-degree angle line AB1 and take the size of AB1 is equal to 100 mm or 10 cm. This AB1 line is indicate true size. Next, draw vertical line from B1 point up to this horizontal reference. Next, draw 30-degree angle line from A point up to this vertical line and mark here B point. Now, this AB line indicate isometric size. Next, divide this true size AB1 line into 10 equal parts because as per given data, the size of AB1 line is 10 cm. So mark here 10 mm or 1 cm division point and write down here 0, 10, 20, 30, 40, 50, 60, 70, 80 and 90 mm size. Now for its isometric size, draw vertical line parallel to B1 O line up to this isometric size line. So first draw vertical line from 90 mm size point. Similarly draw vertical line from 80, 70, 60, 50, 40, 30, 20 and 10 mm true size point. Now the intersecting point of this vertical line on AB line is indicate here 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100 mm isometric size. As per given data, here we need to locate 55 mm length. So first locate 55 mm length on true size which is in between 50 and 60 mm. Mark here P point. From P point, draw vertical line up to this isometric size AB line and mark here P dash point. This P dash point indicate 55 mm isometric size which is reduced by 0.816. Here AB1 indicate true size, AB line indicate isometric size, AP is equal to 55 mm true size on AB1 line, AP dash is equal to 55 mm isometric size on AB line and isometric size is equal to 55 into 0.816 is equal to 44.88 mm. So this is indicate isometric scale or reduced scale for 100 mm length. Next, solve example number 2. A cubical tank of 1 meter into 1 meter into 1 meter was required to be fabricated for storing water. In this regard, isometric projection of the mentioned specification was prepared and supplied to the fabricator. The fabricator fabricated the tank considering it as isometric drawing. Determine the reduced water storing capacity of the fabricated tank. As per given data, first consider isometric view or drawing of cubical tank, then consider isometric projection of cubical tank and find out its volume separately, and next find out its reduced storage capacity. Here you can see rough drawing of isometric view or drawing of cubical tank. Here length, width and height is as per given data 1 meter. Next, here you can see isometric projection of cubical tank. In isometric projection, true size is reduced by 0.816. So, 1 meter length, width and height is reduced by 0.816 meter length, 0.816 meter width and 0.816 meter height. Next, find out storing capacity for isometric view or drawing of cubical tank. For finding storing capacity, first we need to find volume V1 for isometric view or drawing of cubical tank. So, volume V1 is equal to length into width into height, and which is given 1 meter. So, volume V1 is equal to 1 meter cube. Water capacity V1 is equal to 1000 liter because 1 meter cube is equal to 1000 liter. Similarly, find out volume V2 for isometric projection of cubical tank. Here, length is 0.816 meter, width is also 0.816 meter and height is also 0.816 meter. So, V2 volume is equal to 0.5433 meter cube. So, water capacity V2 in liter is equal to 543.3 liter. So, reduced water storing capacity is equal to V1 minus V2. The value of V1 is 1000 and the value of V2 is 543.3. So, final answer for reduced water capacity is equal to 456.66 liter. Next, let us solve third example. A customer asked the shopkeeper to give an aluminum sheet of 1 meter into 1 meter size. Shopkeeper gave the sheet by measuring with isometric scale. How much percent less sheet is given by shopkeeper to customer? Now here, as per given data, first find out area of this given sheet as per isometric view or drawing, and next find out area of this sheet as per isometric projection. Here you can see the rough drawing of given sheet. Length and width is given 1 meter and this is indicate isometric view or drawing of aluminum sheet. Here you can see the rough drawing of isometric projection of aluminum sheet. In isometric projection, size is equal to 0.816 into true length. Here true length is given 1 meter. So, length and width of this aluminum sheet for isometric projection is 0.816 meter. Next, find out area A1 for isometric view or drawing. So, area A1 is equal to length into width. Here, the size of length and width both are given 1 meter. So, area A1 is equal to 1 meter square. Next, find out area of sheet for isometric projection. So, find out A2 area is equal to length into width. In isometric projection, the size of length is 0.816 meter and the size of width is also 0.816 meter because the actual size of length and width is given 1 meter. So area A2 is equal to 0.6658 meter square. Lace area is equal to A1 minus A2. The value of A1 is 1 meter square and the value of A2 is 0.6658 meter square. So lace area is equal to 0.3341 meter square. Next, find out percentage lace sheet given by shopkeeper to customer is equal to A1 minus A2 divided by A1 multiplied by 100. So, the lace area is 0.3341 meter square divided by A1 area is 1 meter square multiplied by 100. So, lace area of sheet in percentage is equal to 33.41%. So, this is the end of this session. See you soon in next coming video lecture. Thank you.